Hi, are you planning to master Amazon EKS service or just getting started to learn containers and Kubernetes? If the answer is yes, you're in the right place. This is a multi-part Amazon EKS deep dive series where we will cover various aspects of running workloads on Amazon EKS. Let's get started. Traditional EKS with EC2 worker nodes remains the most popular deployment model, and for good reason. There are no additional EKS charges for the worker nodes themselves. You simply pay standard EC2 pricing. This gives you maximum flexibility with EC2 purchasing options. For example, if you are running 3T3 medium instances, your monthly cost would be approximately $100.44 for on-demand pricing. However, with a 1-year reserved instance commitment, that drops to $63.87 per month. And if your workloads can tolerate interruptions, spot instances can reduce cost to around $30.13 per month, representing a 70% savings. This deployment model is ideal when cost optimization is critical and you have the expertise to manage the underlying infrastructure. You get full control over instance types, scaling policies, and can leverage all EC2 cost optimization features. AWS Fargate provides a serverless container experience where you pay only for the vCPU and memory resources your containers actually use. This eliminates the need to provision and manage EC2 instances. Fargate pricing is based on per second billing with a 1-minute minimum. In the US East 1 region, you pay 4.048 cents per vCPU per hour and 0.4445 cents per gigabyte of memory per hour. For a typical container with 1 vCPU and 2 gigabytes of RAM running continuously, your monthly cost would be approximately $35.40. Fargate is particularly cost-effective for variable workloads that don't run continuously, development environments, or when you want to eliminate infrastructure management overhead. The serverless model means you are not paying for idle capacity, making it ideal for batch jobs, scheduled tasks, or applications with unpredictable traffic patterns. EKS Auto Mode represents Amazon's newest approach to Kubernetes management, providing a fully managed experience that goes beyond just the control plane. This is designed for teams who want to focus on applications rather than infrastructure management. The pricing structure includes the standard cluster management fee of 10 cents per hour, plus an additional compute management fee that varies by instance type. For example, AC6A.2x large instance incurs an additional 3.672 cents per hour, while an M5AX large adds 2.064 cents per hour. What you get for this additional cost is significant. Auto mode includes managed Carpenter for intelligent auto scaling, the AWS load balancer controller, EBS CSI driver, and integrated storage and networking management. All of these components are automatically configured, updated, and maintained by AWS. This deployment model is ideal for teams new to Kubernetes or organizations that prioritize operational simplicity over cost optimization. While it's more expensive than traditional EKS, the reduced operational overhead can justify the additional cost for many use cases. EKS hybrid nodes enable you to run Kubernetes workloads on your own infrastructure while still leveraging the EKS control plane. This is particularly valuable for edge computing scenarios, data residency requirements, or when you have existing on-premises infrastructure investments. The pricing follows a tiered structure based on vCPU hours consumed. The first 576,000 vCPU hours per month cost 2 cents per vCPU hour. The next tier of 576,000 vCPU hours drops to 1.4 cents, then 1 cent for the next 4.6 million vCPU hours. At the highest tier, over 11.5 million vCPU hours, the cost drops to just 0.6 cents per vCPU hour. This tiered pricing makes hybrid nodes increasingly cost-effective at scale. For example, if you have 50 edge locations, each with 3 nodes and 8 vCPUs, your monthly cost would be approximately $387 per location. The more locations and compute you have, the better the per unit economics become. Beyond compute costs, there are several additional components that contribute to your total EKS bill. Storage and networking costs can be significant, especially for data-intensive applications. For storage, you have several options. EBS-GP 3 volumes cost 8 cents per gigabyte per month and are suitable for most general-purpose workloads. EFS standard storage costs 30 cents per gigabyte per month but provides shared file system capabilities. Networking costs include load balancers and data transfer an application. Load balancer typically costs around $16.20 per month plus usage-based charges. Data transfer out of AWS is free for the first 100 gigabytes, then costs 9 cents per gigabyte. Cross availability zone data transfer costs 1 cent per gigabyte in each direction, which can add up for chatty applications. Let's look at some real-world pricing scenarios to put these numbers in perspective. I've calculated costs for different deployment models using typical configurations. For a small development environment with traditional EKS and 2 T3 small instances, you are looking at approximately $128 per month. This includes the control plane fee, compute costs, and basic storage and networking. For medium production workloads, the cost differences between deployment models become more pronounced. Traditional EKS with optimized EC2 instances cost around $595 per month. EKS with Fargate for the same workload cost approximately $420 per month, making it more cost effective for this scenario. However, EKS auto mode jumps to $1,285 per month due to the management fees. Hybrid nodes would cost about $387 per month per location. The key insight here is that cost varies dramatically based on your deployment model and scale. There's no one-size-fits-all answer, which is why understanding your specific requirements is crucial. Cost optimization for EKS requires a multifaceted approach. Let me share the most effective strategies I've seen organizations implement successfully. Right sizing is fundamental. Monitor your CPU and memory utilization regularly and adjust instance types accordingly. Many organizations over-provision resources and waste significant money on unused capacity. Spot instances can provide up to 90% savings for fault-tolerant workloads. This includes batch processing, CI/CD pipelines, and stateless applications that can handle interruptions gracefully. Reserved instances offer substantial savings for predictable workloads with 1 to 3 year commitments. Cluster consolidation is often overlooked but highly effective. Instead of running separate clusters for development, staging, and production, Consider using namespaces and RBAC to share clusters across environments. Storage optimization involves choosing appropriate storage classes and implementing lifecycle policies. Finally, invest in monitoring tools like AWS Cost Explorer, AWS Split Cost Allocation Data, Kubecost, or third-party solutions to maintain visibility into your spending patterns and identify optimization opportunities. Selecting the appropriate EKS deployment model depends on several key factors. Let me provide you with a decision framework based on common organizational characteristics. Choose traditional EKS with EC2 when you need full control over your infrastructure and cost optimization is critical. This model requires more operational expertise but provides maximum flexibility and the lowest cost when properly optimized. EKS with Fargate is ideal for serverless container workloads and applications with variable traffic patterns. It eliminates infrastructure management overhead and provides automatic scaling, making it perfect for development environments and unpredictable workloads. EKS Auto Mode is best suited for teams new to Kubernetes or organizations that prioritize operational simplicity over cost optimization. The additional management fees are often justified by reduced operational overhead and faster time to market. Hybrid nodes are the right choice for edge computing scenarios, data residency requirements, or when you have existing on-premises infrastructure investments. The key factors in your decision should include your team's expertise level, cost sensitivity, operational requirements, and compliance needs. As we wrap up our deep dive into EKS pricing, let me highlight the essential points you should remember. These are the key takeaways that will help you make informed decisions about your EKS deployments. First, EKS pricing has multiple components beyond just compute costs. Always factor in cluster management fees, storage costs, and networking charges when calculating your total cost of ownership. Second, auto mode simplifies management significantly but may cost more for large workloads. Evaluate the trade-off between operational simplicity and cost optimization based on your team's capabilities and priorities. Third, hybrid nodes enable edge computing with tiered pricing that becomes more cost-effective at scale. This model is particularly valuable for distributed architectures and compliance requirements. Fourth, cost optimization requires ongoing monitoring and right sizing. Set up proper monitoring and regularly review your resource utilization to identify optimization opportunities. Fifth, choose your deployment model based on your specific requirements and expertise level rather than following industry trends. Finally, always use the AWS pricing calculator for accurate estimates based on your specific configuration and usage patterns. To help you continue your EKS pricing journey, I've compiled essential resources you should bookmark and reference. These will provide you with up-to-date information and tools for ongoing cost management. The AWS pricing calculator at calculator.aws is your primary tool for generating accurate cost estimates. It's regularly updated with the latest pricing and includes all EKS deployment models. The official Amazon EKS pricing page at aws.amazon.com/EKS/pricing provides comprehensive pricing information and is updated whenever AWS announces pricing changes. The EKS Auto Mode and Hybrid Nodes documentation on the AWS website contains detailed technical information and best practices. For ongoing cost management, leverage AWS Cost Explorer for analyzing your spending patterns and KubeCost for Kubernetes specific cost allocation and optimization recommendations. These tools provide the visibility you need to maintain cost efficiency over time. Your next steps should be to evaluate your specific requirements, calculate costs for different deployment models, and start with a pilot deployment to validate your assumptions before scaling to production.